Columbus.
No, this is a video.
And this is student handout 3. We learned our 4 definitions: complementary, supplementary, vertical, and adjacent. Those were dealing with just angles. Now we're moving on to triangles. Triangles. So how many angles do you think is in a triangle? 3. So now we're combining 3 angles together and taking a look at that to see the uniqueness of triangles. So first we're going to look at the uniqueness of the angles of triangles. And it says triangles are named by the 3 angles. Angles can be named in 2 different ways, 3 different ways actually. So I have this triangle ABC here. And it says angle A can also be named 2 different ways. So if I'm talking about angle A, I can combine all 3 of those letters, but who better be in the middle if I'm talking about angle A? A. So how else could I name angle A? CAB, and what else? BAC. Okay. As long as A is in the middle, I know I'm talking about angle A. Well, what about angle B? How could I name that one? ABC and CBA. Then, lastly, angle C. How could I name that one?
I didn't realize this was
ACB and BCA. Page 7. Okay. Something unique about triangles is the sum of all 3 angles add up to something unique. So I have a piece of paper here, and I'm going to cut me a random triangle out of this paper. And we agree this is a triangle here.
Yes, ma'am.
Okay? The sum of any triangle is unique. If I take all 3 angles off of this paper, and I would put them together side by side, they form something unique that we learned about in the last 2 lessons. It forms a what?
triangle.
Supplementary, meaning it adds up to what? 180. So all 3 of these angles add up to a straight line. They make a straight line and add up to 180. It doesn't matter what kind of triangle I have. If I rip their angles off, they all add up to 180. So the sum of 3 angles of a triangle is 180 degrees. Says using this information about triangles, you can set up equations to determine any missing angle measures, just like we did with angles. We can use equations to help problem solve. Okay, that's the uniqueness about their angles. Now I'm going to look about their sides. So now we're talking about their side lengths. Side lengths of a triangle corresponds with the angle measure opposite the side. Okay? So what this statement says is the angle determines the side length of the side opposite of it. So if I had my hand put together like this, If I made it squishier, the line of my fingertips touching is shorter, right? If I spread my hands out like that, the line across is longer, but the angle is also wider, correct? So the size of the angle is determining that line between my fingers. Okay, so looking at triangle ABC, says side AB, which is this side here, corresponds with a certain angle. What's opposite of that? What angle is opposite AB? It's just with a letter. What angle is opposite of it? C is opposite line AB. So angle C is determining how long line AB is. So if angle C is real small, AB is going to be real short. Okay, look at BC. Who is determining that size? Angle A across from it. And then CA is this line here. What angle is determining that one? Angle B is determining its size. Okay, so it says the smallest angle. So if I had a triangle like this one here, I would say that this angle is the smallest angle, right? This one would probably be the largest. It's obtuse. But this one is pretty small. It says the smallest angle is opposite what kind of side? Is it going to be the longest side if it's the smallest angle? Earth to people? No. I have a smallest angle is opposite what kind of side then? If it's not the longest, it's the shortest side. Well, here's my largest angle. What kind of side is opposite the largest angle? The longest side. A side is congruent to another side if it has this equal lengths. There is a symbol for congruent, and it is an equal sign with a squiggly up top. That is the symbol for congruent, so you might want to add that. So we did not want to write the word congruent because we're terrible spellers and we'd probably misspell it, so we came up with the symbol. Equal sign with a squiggly. Because I'm not the best writer. Yeah. Okay, we're going to learn 6 new words. Triangles can be classified according to their side lengths and angle measures. Some of us might already know these words. So there's 3 words that's associated just with their side lengths. That is equilateral, isosceles, and scalene. Okay? So we're talking about the angle, the triangle sides. So what do you think an equilateral would mean about their sides? They're equal. What's all equal? The sides are all equal. And how we show that is with these little tick marks here. They all have 1 tick mark. So every side with 1 tick mark is going to mean they are congruent. So an equilateral has 3 sides R, and we used our new symbol here, the congruent symbol. All three sides are congruent. Then we have isosceles. We're talking about their sides here. What do you think isosceles would mean?
Not all equal.
They're not all equal, but something else is unique about it.
Two sides are
Two sides are equal. Isosceles is where two sides are equal. Then you have your two base angles would be equal. Actually, they are congruent. That's why we're using those symbols. I remember isosceles being 2 from the 2 S's right there. I don't know why. It's just how I remembered it as a kid. Then scaling, I remember, was a really weird word, so it formed a really weird triangle. What kind of triangle do you think scaling had?
a one side equal.
Can you have one side equal? What's it equal to? Nothing. So you can't ever say one side's equal. So what can I say for scaling? All sides are different. There are no equal or congruent sides. Is a scaling.
I'm just gonna remember it by scale.
Okay.
What's the word scaling mean?
It says
No sides are equal or congruent.
How can you not read that?
What it's mean? Choose square triangle. Okay, that's talking about their side lengths. Now we're going to talk about their angles. And we've heard these words before, acute, obtuse, and right. But we're talking about a triangle, and a triangle has how many angles?
3.
3. Okay, so we're talking about all 3 of them. Well, here is a cutout of an acute triangle. It has 3 angles, right? Is any of the angles obtuse?
If you look at it from like that.
I can look at it anyway. I don't see any obtuse angles. Obtuse means it has to be larger than what? 90. Do you see any angles that are larger than 90? I'm looking at the angles. Okay, do you see any angles that are exactly 90? You see any that's exactly 90?
No.
No. So, acute triangle has how many acute angles?
3.
3 acute angles. That is how you know it's an acute triangle. It has 3 little acute angles. Okay, here's an example of a right triangle. Do you see the right angle?
Yes.
I see the right angle right here in the corner. These other 2, are they also right angles? No. Are they obtuse? What are they? They're 2 acute angles. So if I have a right triangle, how many right angles do I have?
2.
Right angles.
1, 2.
Right angles.
1.
It's still the same triangle. It has 1 right angle. And how many acute angles? 2. So it has 1 right angle and 2 acute angles. Okay, then an obtuse angle. Here's an example of an obtuse angle. Obviously, this big angle right here would be obtuse. He's greater than 90. What's unique about these other two angles? They're acute. So if you have an obtuse triangle, how many obtuse angles do you have? One with two acute angles. So all triangles is going to have at least how many acute angles? Two. But some of them have a right, an obtuse, or another acute. All right, let's practice with our new knowledge here. So I have 4 triangles here, and A says which side corresponds to angle MNO. So first, what triangle am I even looking at? The first one. And I need to know what side corresponds to angle MNO. So what angle am I looking at? What letter of the angle am I looking at? How did you know N? It's the middle. So I'm looking at N here. And I need to know what side corresponds with MNO, that N. What side corresponds with it, meaning it's opposite of it. Who's opposite of it? It's not just one letter. It's that. It's this whole line, which would be MO or OM. And we like to draw a line on top of our lines so that we know they are lines. So it is MO. Confused?
Why did you say N again?
Because N was in the middle of the 3 letters.
Is it always gonna be like that?
Whatever's in the middle is what I'm looking at. Okay, let's look at B. It said what side corresponds with angle TUS. So this time I'm looking at what triangle? The third one.
We'll call it tugs.
What angle am I focused on? U. So I'm looking at U, and I want to know what side corresponds with U. So is opposite of it. What side is opposite of U? ST or TS with a line drawn across it, over it. C says which side corresponds to angle VXW. So I'm looking at the last triangle. VXW. What angle am I looking at? X. And I need a side opposite of that. Who would that be? WV or VW.
So
This is easy.
most of the time it's always just gonna be like, if you look at it in the middle, you see like the Q. I mean, you see like the X, it's always gonna be the 2 letters that are outside of it.
That's how a kid, one of my students at Molo told me he remembered it.
Is that really always gonna be the answer?
Yep.
Just the 2 letters
If
outside?
that's what they're asking for. Yep. Okay, D says which angle will be the smallest in triangle PQR. Okay, so I'm looking at this second one, but do I have the knowledge right now of all 3 angle measurements? No, I know right now P is an acute angle, R is a acute, Q looks acute, but can I just answer it based on looks? No. So we learned something about the angles of a triangle. I put all the angles together, and what did it make? 180 degrees, right? So I know all 3 angles of a triangle should add up to what? 180. So how can I find Q then?
I don't know, but it could be actually 77.2 because R and Q looked exactly the same.
We can't go on looks, because they're gonna try and deceive you from looks. So 3 angles of a triangle add up to how much? 180. So how can I find Q?
Subtract 77.2 by.
I gotta do 180 minus what? 77.2 minus 41.4, and I have 61.4 left. So what is the measure of angle Q?
61.4.
61.4. Okay, now I can go back to my question. It asks what angle is the smallest in triangle PQR?
P.
Who is the smallest? P. But do I just say P? No. How do I write it where I give them the answer of a P? P has to be in the middle. So the middle,
RPQ,
I could say RPQ, or I could say
QPR.
QPR. Correct.
Also, the smallest one would go in the middle in this situation.
Well, they're asking for the smallest. I know P is the smallest, so P better be in the middle, and I list the other 2 off to the side. Okay, E says which angle will be the largest in MNO? Did they give me all the information I need in MNO? What does that box mean?
So yeah, it kind of does.
What does that box mean?
Right angles 90.
90 degrees. So Chance says it kind of does give me all the information I need. Well, if I have a 90-degree angle, the other 2 angles have to be what? Acute. So is this missing in angle gonna be bigger than 90? No, it's gotta be smaller. So they're asking which angle will be the largest in M and O. Who has to be the largest? O. So how do I say that? N-O-M or M-O-N? Because O is the largest in this case. F asks, how can angle MON be classified? So we're looking at the angle. What angle am I really looking at then? O. And what measure is angle O? 90. So how can I classify that? It is a right angle. Very good. Yes, sir?
So if when your axis is that, when your axis is that, then that means like the highest one is the
You just asked for M-O-N. O was in the middle, so I looked at O. O is a right angle, so I said it was a right angle. You're trying to find too many tricks.
yeah.
Otherwise, I do that.
All right. Let's take a look at number 2. They want us to find B. Did they give us what B was? No, but they gave us the other 2. How do I find B? All 3 angles of a triangle add up to how much? 180. So how do I find B? 180 minus 81 minus 32. And I see that B is 67 degrees. Okay, I'm going to give you about 1 minute. See if you can find 3 and 4 for me real quick. Okay, on number 3, what does that box mean?
Oh, that's 90 degrees.
That's 90-degree angle. So they wanted us to find F. Camille, what did you get for F? 45 degrees. Do we agree or disagree?
Agree.
It was 45 degrees. How did we get that?
It we did 180 minus 45 minus 90 gives you
180 minus 90 minus 45, and we had what was left.
Or you could just add up 45 plus 45 plus 90 makes you 180.
Yep. Okay, number 4, Tristan, what did you get?
I got 101.
101. Did anyone else get 101?
Nope, I got 71.
Okay. Ryler, you got 71. Did anyone else get 71?
You sure?
Okay.
Yep, sure.
180 minus 51 minus 58 gives me 71
I
degrees.
don't understand that. I subtracted 51.
Well, you might have had a typo when you subtracted. Okay. Looking at number 5, did they give us a diagram for number 5 to go by? No. So I like sketching a diagram. It says triangle JHL. So I'm just going to draw a random triangle and write JHL. Does yours have to look like mine?
No.
No, it's just a sketch to help me. Says angle HLJ has a measure of 65 degrees. So what angle has 65? L has 65. Okay? Then it says angle LJH has 50 degrees. So what letter really has
J.
50 degrees? J has 50 degrees. They sketched a different diagram. Actually, oh no, I just switched mine around. Is ours the same?
Alike.
They're similar, but does it matter that they're different? No. Okay, can I still figure out what the missing H angle is?
Yes, ma'am.
So I would take 180 minus 65 minus 50. And what would angle H have to equal?
65.
Is it 65?
Yes, ma'am.
It does equal 65. Very good. All right. Last 3 here. Number 6, I have triangle ABC, and each side has 2 tick marks. So, classifying by its side, if you go back to that chart we just looked at, there are 3 words we could call it. We could call it equilateral, isosceles, and scaling. Well, all sides have 2 tick marks. So that tells me what about their sides? They're all the same. So what would this be? Equilateral, isosceles, or scaling? Equilateral. Because all sides are the same. Now we have to classify it by its angle. But did they give us the angles? No. They said C is X. Well, if all sides are the same, then all angles have to be the same. So A is also X, B is also X. So I need to have an equation to help me solve this. How many total X's do I have?
3x.
3X. And what should it equal?
180.
180. So how can I find what X equals?
Divide by 3.
Divide by 3. Why did I not minus?
Because
Because
3 is married to X.
Because 3 what?
I said 3 is married to X.
3 is married or multiplied by X. Opposite of multiplication is division. 180 divided by 3 is how much?
60.
So X equals 60. So each angle equals 60. So classifying by their angles, we can call it an acute, obtuse, or a right triangle. But all of the angles are 60. So what kind of triangle would this be? Acute. Why acute? They're all under 90. Very good. Okay, looking at triangle DFE. I I think I want to find x first. How do I go about finding x?
180 minus 118 34.
Minus 34. So x equals 28 there. So if all sides were equal, then all their angles would be equal. Are all the angles equal? Are any of the angles equal? So are any of the sides equal? So what kind of triangle is this based on its sides? It can only be equilateral, isosceles, or scaling. It's a scaling because no sides are equal. Well, based on its angle, it can only be an acute, an obtuse, or a right. What told you obtuse?
180.
100.
118.
Huh?
It has
118. And what about 118 told you obtuse?
It's over 90.
It's over 90. So that angle E is an obtuse angle, so that made the whole triangle an obtuse triangle. Yes, sir. I look at all three of them and look, it's based on its largest angle. Okay, 8, what's that square mean? 90. Okay, I need to find x. Someone, how do I find x? 180 minus 90 minus 57. 33, y'all get? So this equals 33 degrees. So let's look at its angles. Is it an acute, obtuse, or a right triangle? What told you right? 90 degrees. It has a right angle, so it's a right triangle. Now its side. Are any of those angle measures the same? No. So can any of the sides be the same? No. So what kind of side definition is it?
Scaling.
Scaling. Very good. All right. So tomorrow I'm checking homework 3. However, I am also just checking last week's work, which was what? Homework 2 and that worksheet that you got last week, remember? The puzzles? So I'm checking quite a bit tomorrow, and if it's not done, where will you end up?
Working lunch.
Working lunch. So, thanks for listening. Have a great day. Like, subscribe, hit the notification bell, and peace out, llamas.
Oh, God.